I recently published a video on experimental ways that you could blend filaments to 3D print in almost any color, adopting a similar method to 2D printers using cyan, magenta, and yellow. However, that method currently only really works with the Snapmaker U1 using a special fork of Orca Slicer, with the exception of a specific model, the one that I printed in my last video, where someone had manually designed a model split into 3 parts, one for each color. But this got me thinking, this is effectively just painting the model but with extra rules, and I figured that this should be relatively easy to automate. So with the help of Claude and iterating over 50 versions to get it right, I have produced a tool that I've called Primed 3D, which allows you to upload any STL, paint it similarly to how you would with your normal slicer, but using any color you like, and then have it export the pre-painted 3MF with those colors converted into dithered color layers of cyan, magenta, and yellow. Because this color dithering method requires printing very thin layer lines and features multiple filament changes, usually per layer, as with the methods covered in my previous video, although this is technically compatible with basically any FDM printer, it's generally recommended to only use this with a printer fitted with a nozzle changer or a tool head changer to avoid excessive purge waste. Though, as we'll see in a bit, there is an exception which makes this more than suitable for a dual nozzle printer such as an H2D. Now, I'm sure you want me to stop talking and just show you the tool already, so let's take a look. So here we can select an STL to upload. It does handle fairly complex STLs, but although this is a web tool, as all of the processing is happening locally, performance will be relative to the computer that you're running it on. Once it's uploaded, you're able to look around and inspect the model as you're likely used to. The navigation controls are shown in the bottom here, but in short, right click and drag to rotate around the model, middle click and drag to pan, scroll to zoom in and out, and left click to paint, which we'll get to in a minute. Up here you can turn on and off the wireframe view to better inspect your model, as well as turn the ground plane on and off. Then here are predefined camera angles to easily jump to different views, which you can also access by pressing Ctrl on Windows or Command on Mac and numbers 1 through 6. Now the first thing you want to do here before painting is ensure that your model is in the same orientation that you plan to print it in. Because this works by applying the paint in thin lateral lines, if you were to paint and process it here and then import it into your slicer and reorientate it, those lines would no longer be running laterally. For the same reason, it's also important that if you wanted to scale the model at all, you'll want to do that before you import it into Primed 3D. If you scale the model after exporting from Primed 3D, the paint lines will be scaled too. I am planning on adding a scaling feature inside the tool, but for now you'll want to scale before importing. To reorient the model inside Primed 3D, click the Orient button at the top here, then just click on the face of the object that you want facing the build plate. Effectively just click the bottom of the model. You can reorient your model at any point in Primed 3D before you hit process, but I would recommend doing this first just so you don't forget. Obviously, if your model is already in the correct orientation, you can skip this step. Now, onto painting. The first step is to choose the base color of your model. So this will be the color of any part of the model that you don't manually paint. You can either enter a color hex code or click the box here to manually select a color. There's a color picker here, and if you select this, you can click and select any color currently visible on your screen, even if it's outside of the browser window. Alternatively, you can drag across this bar until you see the color gradient that you like. Then you can select the color that you want from the palette up here. For now, we'll leave the selection in the top right of this palette, and we'll talk a bit more about this in a minute. Now we have the painting tools. Here we have the tools themselves, and beneath that we have another color selector, which features the same system as above. This is the color that we'll use with our painting tools. With the brush tool selected, we can set a brush size and then paint directly onto the model. The brush tool and the spherical brush tool can be used in basically the same way. They do work and can be really useful, but they aren't perfect and have a lot of bugs, especially when you set them to a particularly small size. So whilst I continue to work on them, use these but with a pinch of salt. We then have the fill tool. This has two modes. Connected will fill everything connected to the point that you select up to the border of another colour. So here I've got a circle that I painted with the brush tool. If I then select the fill connected tool and click in the middle of it, it paints everything in that area up to the point it meets the painted lines. This can be really useful. Either if you paint the border of the area you want, then use the fill tool, you can fill the rest in. Or if you've already painted an area but changed your mind on what colour you'd like, you can just change the entire painted area to a different colour. The angle limit option allows you to select an angle, then it will paint the model from the point that you selected up to that angle in the geometry. With the painting applied, you can still go back and change the base colour and it won't affect any of the applied painting, but you can also click Reset All to Base if you'd like to just start over. Now we have one more step before we process it. We've been talking about producing new colours by mixing cyan, magenta and yellow, or CMY. And that's what's selected by default here. However, if you wanted to have significantly darker colours on your model, or if you wanted to feature black itself, you'd want to include a black filament in there as well. Equally, if you wanted particularly light colours, or you wanted to feature white or grey, you'd want to include a white filament in there as well. This drop down allows you to select which colour filaments will be available for use. Cyan, magenta and yellow, or CMY, CMY plus white, CMY plus black, which is referred to as K in this, or CMY plus white and black. Remember I mentioned earlier that we'll leave the colour selector in the top right corner of these palettes. Well, that's because this is the pure colour. If we slide the picker to the left, it's adding white to create that shade. If we slide the picker down, it's adding black, and anywhere else it's a mix of the two. Once you've selected your filament mode, next you can just click Process. You can then download your model as a painted 3MF. Currently this is only compatible with Bamboo Studio and certain versions of Orca Slicer, as other slicers that I've tried this with strip away the colour data on import. Whilst you can use those slicers to slice for basically any FDM printer, I know that that's not everyone's preference, and I am working on expanding the compatibility to other slicers. In Bamboo Studio, import your new 3MF. You'll likely have a pop-up like this come up saying that the 3MF isn't from Bamboo Studio and that you'll only be importing the geometry and colour. Just click OK on that and it will continue. You'll then be able to map the pre-assigned colours to your cyan, magenta and yellow, and black and white if you've used them. Currently this is the first time that you'll get to see the dither painted version of your model. Now it may look excessively stripy and possibly a bit messy, but this look is amplified in the slicer's view, and as you'll see shortly, it often looks significantly more uniform once printed. If you want to see a little bit better how it will look, try zooming out and see if it blends the colours a bit more in the slicer. Settings wise, make sure you have it set to a layer height of 0.08mm. The default 0.08mm profile in Bamboo Studio should be fine. Without going into unnecessary fine tuning and tweaking, there isn't really any other special settings that you need to do in your slicer. As I said, don't scale or reorient the model after exporting from Prime 3D, but you can obviously still rotate it around the Z-axis. So let's get this printed. The colours on this Benchy have come out very close to what I painted in Prime 3D, and they've come out a lot bolder and flatter than I thought they were going to after I saw the layer lines in the slicer. I also included this little cube on the same print, just as a test of the contrast of colours, and each came out really well. As I mentioned in my previous video, this primarily works with the vertical faces of a model as the colours are produced using lateral colour lines. As a result, the top and bottom surfaces of a model aren't controlled in the same way as you can see on the top and bottom faces of this cube. Currently, there's no way of controlling the colour of top and bottom horizontal surfaces in Prime 3D, but I'm planning on adding a function that will vary the colour of the outer 3 to 4 layers so that the light that permeates those layers will cause a certain level of colour blending. That Benchy and cube were both printed in just cyan, magenta and yellow, But let's see how different a model looks when we process the same model with the same painting applied, one with just CMY and one with CMYK, which also includes black. Here I painted up a Kali dragon with slightly darker colours. Let's see how Prime 3D interprets these colours when it doesn't have access to black to darken them down. They look quite different from each other in Bamboo Studio, with the CMYK one maybe looking closer to the colours that I'd originally painted. Let's see how they print. Well, they've both come out really well. The definition in the colours is actually really good, and the blues of the bellies and the purples of the antlers are actually pretty indistinguishable from one another. It's the greens that seem to have really shown change. The greens on the CMY print that didn't feature black does actually seem to be a lot more uniform and looks a lot cleaner. Like, you wouldn't necessarily know that that was produced using a mix of colours. The one that featured the black as well is closer to the colour that I painted at, a darker green, but the black lines make it much more obvious that we've got this layered coloration, and it does look more messy. It might actually be beneficial if you're looking for a more textured colour on the model, but the one without the black in it, just the CMY, does look cleaner of the two. For another test, whilst both printed with CMYK, so with black, one of these cats uses colours just from the top right corner of the palette, effectively not requiring black or white, and the other one features more custom colour choices. This shows how that can impact the print even if you include the option of black filament. Of these two, it's clear that the one that had the lighter colours and therefore didn't need to use as much black looks significantly cleaner and better quality. There's obviously more visible banding on the models that include black. That's partly down to the fact that black is going to blend less smoothly with other colours, but I'm going to try to refine the system so it better distributes the black into the mix. These prints aren't quick, as they use small layer heights and multiple filament changes per layer, but because any model that is being printed using this method uses the same filaments regardless of the colour that those filaments are producing, you could have multiple completely different models on your print bed at the same time and have a surprisingly small impact on the overall print time. I actually printed both the cats and both the Kali dragons at the same time, and as it didn't add much time to the print, I also threw this Grogu on the bed with them. Again, the green mixed with the black lines does make for a more stripy appearance, but on the whole, this does look pretty good. The colours are all very distinguishable, and you can see the pure black in the eyes and inside the mouth. Whilst this really requires a printer fitted with a tool head changer or a nozzle changer, such as a Snapmaker U1, Prusa XL or a Bambu Lab H2C to avoid excessive purge waste, you can paint an object only featuring a range of greys, white and black by only using colours from the left edge of the colour palette and processing it with both black and white filaments. With this, you would be able to print on a dual nozzle printer such as a Bambu Lab H2D and still get zero purge waste, whilst being able to print in more than 50 shades of grey. As a test, this little guy has a range of greys, black and white. I found occasionally solid white or black areas can have a few bands in them, though this may be down to me not selecting true white or black in Primed 3D. Once you import your primed model into your slicer, you can then repaint any section you want, so it was quick and easy to just remove these bands on the eyes and nose. This also means you could use Primed 3D to just paint a certain part of a model in a colour that you don't have access to, and then once it's imported into your slicer, paint the rest as you would normally. The range of greys works really nicely when printed purely with black and white filament. Primed 3D is available to use completely free at primed3d.3drevolution.net. I'll pop a link in the description. If you've not already seen it, I heavily recommend watching my previous video so you better understand how this method works and how certain settings that you change may affect the results. The entire tool is also run from a single web page, so viewing the source code will allow you to see and edit all of the code. Primed 3D is very much a proof of concept, and it's not perfect, But whilst the results may not always be as crisp and clean as the custom-made rainbow egg I covered in my previous video, it is a proof of concept that works, and I hope that for many of you it's an interesting, if not even useful tool to experiment with. As I mentioned at the start of this video, the creation of this tool was with a heavy hand from Claude, and to be perfectly honest, it was largely vibe coded. Whilst I used to be heavily into my coding, and 20 years ago I wrote an entire social media network with Microsoft Notepad, not even Notepad++, it's been a long time since I've turned my hand to a coding project of this scale. That's not to say that this hasn't been without a lot of effort, and at the time of recording, I believe Prime 3D is currently at version 51. And it's not a finished project. As I mentioned, I plan to improve a lot of this and add a lot more features, and I hope that as I put this out there, other people will also do the same and share their iterations. I also plan to add this to GitHub, which I'll link to in the description below once I've done that. If you found this video interesting or useful, please do pop me a like and a hype, it does mean a lot, and subscribe so you don't miss out on my future tutorials, deep dives and explorations. If you have any thoughts on Prime 3D, any suggestions or requests, or if you found an interesting use case for it, please let me know in the comments below, I'd be really interested. If you'd like to support me, bringing you more stuff in the future, you can hit join below any of my videos, getting you early access to my content, some exclusive member content, and a few other goodies. For now, as always, thanks very much everyone, and until next time, happy printing. A huge thank you to my revolutionaries, my channel members, for your support. Without you guys, projects like this just wouldn't be possible. If you'd like to join them, hit join below any of my videos. I've got some exciting stuff on the way, but for now, why not chuck on one of my other videos to learn something new or just have some fun. Thanks very much everyone, and until next time, happy printing.